Okay, so welcome to my channel. Today I will discuss a problem from Dirac delta function chapter, and this is from the HK Das book. Okay, and you will see this problem. Okay, this is the problem, and I am making this video at a student's request. Okay, and I want that if there is any problem with any mathematical problems, okay, then feel free to mail me. Okay, I will try to help you as much as possible. Okay, I will start a playlist also. I think I don't need to spoil my time. Okay, so what is given that f of x equal to 1 by epsilon when mod x and less than equals to epsilon. I mean, you can say e or epsilon or what you feel free to say, and this is 0 when delta x is greater than t. Fine. So I think you all know. I think you are doing the Dirac delta function chapter. I think that you have already the knowledge about the mod function, what this mod function says. Okay, so I'm not going to discuss anymore. Okay, so I am going to solve this, okay, directly. But before this, you need to know one thing, that what this Fourier transformation says. Okay, so if you want to do Fourier transform, then you will need to Fourier transform of the function. If there is a function f of x, then Fourier transform will be f, this is Fourier, okay, and f of x equal to 1 by root 2 pi, okay, minus infinity to plus infinity, okay, and f of x e to the power I s6 dx. Okay, so this is the main formula. Okay, I think you have already know about this, because this problem is actually from the Fourier transform chapter. Okay, but here it is given, so I need to do. Fine, so I need to break this function first. Okay, so what you will do, that Fourier transform of f of x. Okay, now I will substitute 1 by root 2 pi. It is already formula says. Okay, so I have nothing to do with this. Okay, and then you can see that mod x less than equal to epsilon. Okay, so the limit will be minus epsilon to plus epsilon, because here this function says that this is a mod function. Okay, so minus epsilon to plus epsilon. Okay, and I will then put the value what is given, 1 by epsilon. 1 by epsilon. Okay, so put this 1 by epsilon. Okay, and e to the power ixx dx. Okay, I have nothing done here, just substitute the values. Okay, so 1 by epsilon e to the power ixx dx. Clear? Okay, now I will do one thing, that I will turn this term, this constant term, to the left. 1 by root 2 pi 1 by epsilon minus epsilon to plus epsilon e to the power ixx. Okay, this is a very much easy integration if you know the formula. Okay, so I am going to solve here. Okay, minus 1 by root 2 pi 1 by epsilon. Okay, and what we will get, I can replace this term by cosine function and sine function. Fine, so 1 by epsilon minus epsilon to plus epsilon. Okay, cos sx plus I minus epsilon to plus epsilon, sorry, sin sx dx. So this is the total integration. You need to do this. Fine. Okay, now you can see that this is the odd function, so the integral value will be 0, and this is the even function. So I need to do this, the integration of this term only. Fine, so 1 by root 2 pi 1 by epsilon into, and as this is even function, so I can change this limit 0 to epsilon, and for this I will multiply this function by 2. Fine. Okay, so 2 0 to epsilon cos sx dx. I have forgot to write here dx. Okay, great, and this integration will be 0. Okay, so plus 0. Okay, here I think it's very much easy. Now you can do it. Root 2 pi 1 by epsilon. Okay, and 2 by epsilon, sorry for this, and sin sx by here dx, so the constant term is x. Okay, and 0 to epsilon. Now put limit, it's very much easy. Okay, so 2 by epsilon root 2 pi. Okay, and you will get sin s epsilon minus sin 0, and you know the value sin 0 is equal to 0 by s. Okay, so from here you will get root 2 by pi. Okay, 1 minute. Root 2 by pi sin s epsilon by epsilon. Okay, I think here is nothing complexity. Okay, but I need to say something, okay, about my channel. Okay, I think I should say this. Okay, I know the I mean that for those who have come to my channel already, okay, I request you to just for one time, okay, at the status, just see my status on my channel. Okay, it's very much disturbed situation. Okay, I earnestly request you to please help me a little, just okay, because okay, I know the condition of my videos, okay, or the style of making my videos. Okay, I am not saying hmm, anything here. Okay, I mean, I know the condition of my videos, of the style of making the videos is disgusting and sinful. Okay, but if I get your help, it won't take me long to recover from this situation. Okay, and one more thing I want to say, that it's not my business. Okay, so my intention is that if my little effort is of little help to someone, okay, then I got a lot of pleasure. Okay, and this pleasure is not malicious. Okay, I mean, this is not a malicious desire also. Okay? I can expect this from you, so please once just see my channel status, and I think you should help me. Okay, because I need more effort to make this type of videos. Okay, and I am trying my best. Okay, so okay, ठीक है, कोई बात नहीं. Okay, so let's start. Okay, but this is not the answer. Fine. So what I need to do now, you can see that the problem is given that the last line, that taking the limit as epsilon tends to 0 and discuss the result. Okay, so I think this is not the answer. Okay, so what you need to do, okay, just take limit. Okay, nothing to do it. Okay, so root 2 by pi. Now take limit epsilon tends to 0. Okay, now this function you can take. Why I have written this in the left side? Because this is the constant term. Fine. So sin s epsilon by epsilon s. Okay, so this is the, I mean, wait 1 minute, f of x equal to this term. Okay, so I have already taken the limit. Okay, now you need to calculate this. Okay, so you can see that if you substitute the value of epsilon, then sin 0 equal to 0, and here also epsilon, so epsilon is 0. So this form is 0 by 0 form. Okay, and if you are doing physics honors or any, if you are taking any competitive examinations preparation, okay, then I think you have already know that if there is any condition type infinity by infinity or 0 by 0 form, then there for limiting condition there will use a rule that will be called, I mean, that is called by L'Hospital rule. What you need to do is that in numerator or denominator also, both I mean both also, you just do derivative of this. Okay, so to remove this type of situation, so I am already taking the L'Hospital rule. I mean just using. Okay, so you can do it, root 2 by pi epsilon tends to 0, and if you do the derivative of this, okay, then here the limit is epsilon tends to 0, so here s is the constant term, so I am taking this in the left side, so 1 by s, and this will be get sin s epsilon. So if you take derivative, then you will get cos epsilon s epsilon into I think constant term s, okay, by epsilon s, I mean 1 by s, so this epsilon will be 1. Now you can see that you can easily found the limit. Okay, so epsilon tends to 0, substitute this, and you will get the value of 1. And if you get the value of 1, then s will be, I need to take one line more, so root 2 pi, I mean this limit will be vanished, so you will get s only. Clear? Because cos s epsilon, and here we will substitute epsilon equal to 0, so cos s epsilon minus cos 0 equal to 1. Clear? So yes, and this s will be removed, so the final result you will get root 2 by pi. Okay, I have not said about any formula of Fourier transform. Okay, I will start a series from H.K. Das. Okay, I mean the solution of Fourier transform, inverse Fourier transform, and I will discuss all the properties of Fourier transform. Okay, so please wait. Okay, and I will start soon. Fine. So what I have said that my intention to make this type of videos is not for any type of business. So it's my hobby. I think I want to help you anymore in my spare time. So you need to help me as much as you can do it. Okay, so please share, subscribe and like also. Okay, because my channel's status is going to be very much distressed day to day. Okay, and I am not so much excited and also I am not happy for this. Okay, please help me, थोड़ा सा help कर दो. Okay, फिर मैं okay I will start, and I have already started the atomic and molecular problems. Okay, from Rajkumar book, and after that I will again start the Fourier transform. Okay, and the integral transforms also. Okay, there I will discuss all of the properties of Fourier transform, and I think you will be comfortable. Okay, so thank you.